Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the January 2024 Mechanics paper M1 from Edexcel International A-Level. This question is the last question of this paper, and here we have an inclined plane. So it's a fixed rough plane, is inclined at an angle alpha to the horizontal, with a tangent of alpha is equal to 5/12. A small smooth pulley is fixed at the top of the plane. One end of a light inextensible string is attached to a particle P, which is at rest on the plane. The string passes over the pulley, and the other end of the string is attached to a particle Q, which hangs vertically below the pulley, as shown in figure 5. Particle P has a mass of m, and particle Q has a mass of 0.5 m. The string from P to the pulley lies along a line of greatest slope of the plane. The coefficient of friction between P and the plane is mu. The system is in limiting equilibrium with the string taut, and P is on the point of sliding up the plane. Find the value of mu. Okay, so this question, few things that I want to explain. First of all, it says a fixed rough plane. Rough plane means we have to consider friction. It's not smooth. Inclined at an angle of alpha, where tan alpha equals 5/12. So for this, what you shouldn't really do, some people would do it, but what you shouldn't really do is you shouldn't find the value of the angle, because they tell you tan of the angle, then we know that we can work out as a fraction, as an exact fraction, the cosine of the angle and the sine of the angle. Because if the tan of an angle is 5/12, that means the ratio of the side opposite the angle to the side adjacent to the angle is 5/12. So the ratio of the opposite to the hypotenuse would be 5 over what length this is, and that's going to be 13. If you work it out, it's the hypotenuse of a right angle triangle. 12 squared, 144, 5 squared, 125, 144 plus 25 is 169. Square root of 169 is 13. Okay, so 5, 12, 13 triangle. They normally give you these Pythagorean triples, okay, in this type of question. Like they'll give you 3, 4, 5. So they'll say the tan of alpha is 3/4. So it'll be 3/5 for sine and 4/5 for cosine, or 7, 24, 25. There's different numbers which are make what are called Pythagorean triples. When you square two of them and add them together, you get the third number. So they normally give you those numbers in this type of situation. And therefore, you don't have to find the angle, because I know if the tan of the angle is 5/12, then the sine of that same angle is going to be 5/13. And the cosine of that same angle is going to be 12/13, right? And, sometimes you're asked to give things in exact form or exact values, and then finding the angle and then finding the sine of the sine of the angle. You end up sometimes getting decimals that you have to round, and it doesn't quite work out. So it's always best to leave it in this form. That's the first thing. All right, so we dealt with that issue now. Okay, and a small smooth pulley is fixed at the top of the plane. Smooth pulley means there is no friction in the pulley. One end of a light inextensible string is attached to a particle which is at rest on the plane, and the string passes over the pulley, and the other end is attached to another particle Q, which hangs vertically below the plane. So when it says a light string, that means we ignore its weight, ignore its mass, we ignore its weight, which means that the tension throughout the rope or the string will be the same all the way through it here, like for this section. Because, if it was something which was not light, okay, if it was something which was, we had to consider it has a weight to it, then parts of it will be holding other parts of it. So for example, the weight here at the bottom, okay, it will hold what's above it, right? So the tension won't be the same all the way through. But if we say it's light, the tension will be the same all the way through, and so we can consider the tension the same all the way through every section of the string. And because the pulley is smooth, that means the tension in the string on either side of it will be the same. And the string being inextensible means all the particles attached to it will have the same acceleration. okay, all the particles attached to it will have the same acceleration, okay, because the string is inextensible. It doesn't stretch, it's not elastic, okay? So now, okay, particle P has a mass that's marked. Now, the other thing, the string from P to the pulley lies along a line of greater slope of the plane. Basically, what that means is if you are looking at this from this angle, for example, you will see something, right? Try and draw it like a perspective. You'll see something like this. You'll see a kind of a ramp. On the top of the ramp, there will be a pulley, and the pulley will be attached to this particle P. Okay, so what they're saying is that the line, the string passes over the pulley. Okay, sorry, what does it say? The string from P to the pulley lies along a line of greater slope of the plane. So basically, it's not like the particle is here and then there's, this diagonal kind of distance. It's the shortest distance from the pulley to the particle that it's attached. Okay, the line of greatest slope of the plane. That's what it means. Okay, something like that. Okay, so when you see that all the time. A lot of students have no idea what it means. It doesn't affect the question really, if you carry on, but just for your understanding so you know, okay, that's what it means. All right. And then it says the coefficient of friction between P and the plane is mu, because whenever you have a rough surface, the friction, there is what's called the maximum value of friction. F max is equal to mu, the coefficient of friction, times R, which is the reaction force. So F max is basically the maximum value that friction can be generated in that situation. So let's just look at an example to explain. You have a box P, for example, and you're pulling if it's on a rough plane. Let's say it's on a rough plane, okay, and it's a rough plane, and you not do anything to it. Just leave it. You have the force acting, its weight, and the reaction force, and you're not pulling it. You're leaving it alone. You're not touching it. So the frictional force acting here will be zero because you're not pulling it. It's not wanting to move. It's on a horizontal surface. It's not going to move if you don't pull it. So the friction will be zero because nothing's trying to move it. If you pull it in this direction with a 1 Newton force, then the frictional force will prevent it from moving. And whatever force you pull it with, it will match that force. So if that's 1 newtons, that will be 1 newtons. If that's 2 newtons, that'll be 2 newtons. If that's 3 newtons, that'll be 3 newtons. It just matches whatever's pulling it. It can never be more than what's pulling it. It just matches it to stop the thing moving. But there is a value that the frictional force cannot reach or cannot exceed, which is called F max. If that force pulling it exceeds F max, then it's going to start moving. It will go out of equilibrium. Okay, so that value of F max is given by mu, which is the coefficient of friction, times R, which is the reaction force between the surfaces. Okay, so that's an idea of what F max stands for. A lot of people don't understand these basic concepts, so that's why I'm taking my time to go through these things before we get to the question. All right, so we're like how long into the question? I'm not sure. Whatever. Now we're going to get into the question because I want to lay the foundations for those people who have had, issues in their learning, okay, up to now. So hopefully that's given us some idea of some of the important things that we have to deal with or think about. So now it says the system is in limiting equilibrium with the string taut and P is on the point of slipping up the plane. So what I'm going to do now, I'm going to draw some of the forces on this diagram here. I'll make it slightly bigger so that we get more space to think or to see. And I'm going to put some of the forces on here. So now we have the weight acting vertically down on both of these particles. Okay, so for this particle, it's going to be 0.5 mg, and here it's going to be mg. You have the tension in the string. In this case, is acting upwards. In this case, it's acting up the plane, pulling on the particle. So this is the tension acting on this particle, and this is the tension acting on this particle. Those tensions are the same because we have a light string which is going over a smooth pulley. Okay, so those two tensions have the same value, right? And what else do we have? that's basically it. We also have the reaction force because this is in contact with the surface, which is important here because we've got friction involved. So this is the contact from the normal contact force. We're going to call it R. All right. Now it says the system is in limiting equilibrium with the string taut and P is on the point of slipping up the plane. Okay, so P is on the point of slipping up the plane. So basically, it's just about to move up the plane. It has reached the limit of the friction, has reached its maximum value above which it cannot go, and it's still in equilibrium. It's not moving. Okay, if any of the forces like the tension or the weight was increased anymore on that side, then it would start moving. So because it's about to slip up the plane, friction is preventing that from happening. So friction is acting down the plane. So down the plane you have F max. Okay, the maximum value of friction has been achieved. Okay, so we have F max. Now we want to find the value of mu. We know that F max is equal to mu times R, which means mu is equal to F max over R. So if we find F max and we find R, we have then found mu. We just divide them. All right, so that's our objective now, to find F max and R. So what we're going to do now is we're going to resolve the forces in a direction which is parallel and perpendicular to the plane. You always resolve the forces in directions which are parallel and perpendicular to the direction in which something will move. Now this would move, okay, along the plane if it was going to move. So we resolve the forces in those directions. Now this is about to slip up the plane. So I'm going to resolve the forces taking up the plane as positive. And for this, okay, this is about to go down. So I'm going to take this and resolve the forces taking down as positive. It really doesn't matter because it's an equilibrium which way you do it. I just like to, that's how I like to think about it. But it doesn't matter which way you do it because it's an equilibrium. The forces on the left and the right will be equal to each other anyway. All right, so now on up and down in this case. So if I look at this one first, this is the easier one to deal with. I can say that basically these are equal to each other. I can even say, doesn't matter, T equals 0.5 mg. So I know the value of the tension in the string. Okay, because equilibrium, it's not accelerating. The upward force and the downward force must be equal to each other. T equals 0.5 mg. Some people say, why don't you use F equals ma? I am using F equals ma, right? F equals ma means the resultant force equals the mass times acceleration. So if I did that, it would be T minus 0.5 mg. What happened to my pen? Sorry, it's got missing. Minus 0.5 mg equals 0.5 a. Now a is 0 because it's not accelerating. It's in equilibrium. So this becomes 0, so I left with T equals 0.5 mg. So I am using F equals ma in all these cases, but when I know that it's in equilibrium, I know the acceleration is 0, so I can just equate the up and down forces together. That's all. Okay, so some people say you use F equals ma sometimes, and sometimes you don't. Sometimes you use just up and down, up force equals down force. Well, when it's in equilibrium, the forces are balanced, so the forces up and the forces down are equal. So therefore, you don't have to put F like T minus 0.5 mg equals 0. It's going to be 0 the other side anyway. That's why. Okay, but it is really using F equals ma with the acceleration being 0. All right, now resolving the forces up the plane. Now, what I need to do here is I need to let me do this down here. Actually, take this down here. I think I'll need a bit more space to write on, so I'll put this down here. Okay, so I need to resolve this weight, okay, parallel to the plane. Okay, the F max and the tension are already parallel to the plane, but the weight is not parallel to the plane. So what I'm going to do is I'm going to draw a little line here. Okay, I'm going to draw a little line over here, and I'm going to just try and make you understand about something which is I've gone through before, but I want to just make this video a very explanatory video so you understand. So I need to resolve this weight in this direction and then also in that direction, because I'm also going to resolve perpendicular to the plane to find the value of R. Now, this angle here, everyone knows is alpha. Okay, everyone knows it's alpha, but not everyone understands why it's alpha. And some students do ask, they say, sir, why is this angle here the same as the angle there? Okay, now, it's not just something just memorize it and shut up. No, I don't like to teach like that. Basically, you have here a triangle, this big triangle over here. Okay, this big triangle over here, which has a right angle in it over there. Okay, let's get rid of this first so that we can concentrate on that. And we also have a small triangle here, which has also a right angle in it. So the big triangle and the small triangle both have a right angle. Okay, the big triangle has this angle as one of its angles, and the small triangle also has this angle as one of its angles. Okay, so basically, this little triangle has a right angle and this angle. This big triangle has a right angle and the same angle. They are similar triangles by angle. Okay, that means the third angle on both of them must also be the same, because if they're similar triangles, then all three angles are going to be the same. So that's the reason why this is alpha. Okay, that's the reason why this is alpha. Okay, it's the same as the angle to which it's inclined. You don't have to prove that, you don't have to really know that, but it's good to understand what you're doing and why you're doing what you're doing. Okay, a lot of students, they do wonder why it's the same, and they never really ask or whatever. Sometimes they do ask, but I just want to make sure that you understand. So now we're going to resolve the forces parallel to the plane. This weight will have a component parallel to the plane. Okay, well, I want that component of the weight. How do I work out what that component of the weight is? Well, the little rule that I like to teach my students is, if you have to resolve the force that you are given in a direction which is away from the angle given, this is the angle given, I have to move away from that angle. Okay, it's like you're finding the opposite side here. So you're going to be using sine. So the component of the weight in this direction is going to be mg times sine of alpha. And the component of the weight perpendicular to the plane, you have to go into the angle to get it, is going to be mg times the cosine of alpha. So this is mg cosine of alpha, right? So I've resolved this force in both those directions. Now I'm ready to resolve the forces. Okay, so parallel to the plane, it's about to go up the plane, as it says. It's about to slip up the plane. Okay, so we can say T is acting up the plane, and that's equal to, because it's still in equilibrium, F max plus mg sine alpha acting down the plane. Okay, and if I resolve the forces perpendicular to the plane, I'll have R equals mg cosine alpha. R equals mg cosine alpha. R equals mg cosine alpha. Right, so now I can write an expression for F max. F max is going to be T minus mg sine alpha, and I can write what R is equal to, and when I've done that, I can find what mu is. So T, as we know, is 0.5 mg. Okay, and sine alpha, as we discussed right at the beginning, is 5 over 13. So we got mg times 5 over, that's 5 over 13, okay, times mg. I'm going to write this as a half because we've got fractions and it'll be better. So this is going to be a half mg minus 5 over 13 mg. Let me give myself a bit more space. I'll deal with that in a minute. So we can say F max is going to be, that's going to be over 13. That will be, if I multiply by, no, that I can't, I make that into 13. It's going to be, I can't make that into 30, can I? 26. Make that into 26. That will be, multiply that by 13. That'll be 13 over 26 mg minus, make that into 26, multiply by 2. That's going to be 10 mg. So I have 13 minus 10 mg, which is going to be 3 mg over 26. So that's F max. I could write it as a fraction, as a decimal, but I'm just going to write it like this. 3 mg over 26 is F max, and R is going to be mg times cosine alpha, and we worked out that cosine alpha is, as we said before, is 12 over 13. Okay, So that's mg times 12 over 13, which is going to be 12 mg over 13. So now we can say, I've run out of space here, but I'll just do this. So I can say here that mu is equal to F max divided by R. Okay, F max divided by R. So it's going to be 3 mg over 26 times 13 over 12 mg. When you are dividing fractions, you write the second one as its reciprocal and you change it to multiplication sign. So it's 3 mg over 26 divided by 12 mg over 13. So we can see here the mg's will cancel out. Okay, you will have 13 cancel out with 26 giving you 2. So we have 3 over 24. 3 over 24, which is 1 over 8. Okay, that's 2 times 12. Good. So 1 over 8. So I've just about run out of space here. So mu is equal to 1 over 8. I guess if you left it like that, it would be fine. But 1 divided by 8 as a decimal is going to give you 0.125. 0.125. It doesn't have a unit, so it's just a constant. As you see, the units all cancelled out. So there we have the answer to part A of this question. We found the value of mu. All right, so that's worth how many marks? 8 marks. Okay, so I went through a long explanation for this question because as I said, my objective is to address some of the things which I hear from my students, some of their doubts and some of their concerns about how to deal with these type of questions, some of their misconceptions. All right, and so that's why I took so long in answering that part. Now let's see part B. What does it say? Okay, it says the string breaks and B begins to move down the plane. So the string breaks and P begins to move down the plane. When the particle P has traveled a distance of 0.8 meters down the plane, the speed of P is v meters per second. Find the value of V. Okay, so now the string breaks. Now when the string breaks, the tension is gone. There's no more tension in the string. So the only force acting on P is its weight, and its weight has a component which is acting down the plane. Okay, so the only force acting on it is its weight, which is mg, as we found before. Mg, that's the component acting on it. That's the only force acting on it, as well as, of course, the reaction force, which is acting up the plane, which is acting perpendicular to the plane, sorry. Okay, so we have this reaction force and its weight. Those are the only two forces acting now because the tension is gone. All right, so it begins to move down the plane. So now it moves a distance of 0.8 meters down the plane. Okay, so it moves a distance of 0.8 meters down the plane. It reaches this point here, so that's 0.8 meters. Okay, and by this point, it's going to be going at v meters per second. Now, of course, when it first starts moving, it's going to be going at 0 meters per second. It starts from rest because it was still at first. All right. Now, because it's moving down the plane, and I mentioned something that's wrong, actually. I said the only force acting on these two. There's also the fact that it's a rough plane. There's the frictional force acting, and the frictional force is going to be acting up the plane. So you're going to have frictional force acting up the plane, and it's going to be F max. The frictional force is going to be F max. Why? Because it's moving. It's moving. They told us it's moving, right? So we want to find the value of V. To find the value of V, we're going to use SUVAT. Okay, we're going to use SUVAT. We have the distance. We're going to take from this point to this point. So we're going to take this distance as positive. So it's going to be 0.8 meters it's moved through. Its initial speed was 0. Its final speed is V, which we have to find. Its acceleration is something that we need. The time is something that we don't really need. But now what it is, we need to work out what the acceleration is. If I know what the acceleration is, I can find what V is. Okay, I can use V squared equals U squared plus 2AS. I can find what V is. And that's our objective now. So we're going to use the forces acting upon this particle to find what its acceleration is. Now it's going to be moving. So we can say that we can talk about the resultant force equals the mass times the acceleration. We can we have to find the acceleration. So we're going to again resolve the forces acting perpendicular and parallel to the plane. We really only need now to think about the forces acting parallel to the plane, because we already know the value of F max. It's going to be the same value as in the last question. So this is going to be, as we mentioned before, this is alpha. This is mg sine alpha. So if we resolve the forces parallel to the plane, I'm going to take down as positive because it's accelerating downwards. I want to find the acceleration. I can say the forces acting down are mg sine alpha, and the force acting up is F max, so minus F max, and that's equal to the mass times the acceleration. Okay, the mass times the acceleration, and the mass is m. Okay, the mass is m, so ma. All right, so now we worked out F max in the last question. Last part of the question. F max is going to be 3 mg over 26. Okay, F max is still going to be the same as before because F max is mu r. Mu is the same, r is the same. Reaction force will be the same. So F max is 3 over 26 mg. So we know that also that the sine of alpha was 5 over 13. Okay, so those were information, those pieces of information we knew from before. That's F max, that's sine of alpha. Those things are the same as in the first situation. So now we can solve this equation with these values. So sine alpha is 5 over 13. So that's going to be 5 mg over 13 minus F max, which is 3 mg over 26 equals the mass times the acceleration. Divide everything by m, the m's will cancel out. So we got 5 over 13. We can add these together. This becomes 10g over 26 minus 3g over 26 equals a. So a is going to be 10 minus 3, which is 7g over 26. So that's acceleration, okay, which, that's not supposed to be there. So we know the acceleration now. So we can use the formula v squared equals u squared plus 2as. Okay, and we don't know v, we have to find it. We know u is 0. We know acceleration is now 7g over 26. And we know s is 0.8 meters. Okay, it's 0.8 meters, so we put times 0.8. So v squared equals, or we can say v is equal to the square root of all that. Let's just put that in our calculator one time. So we're going to end up with 2 times 7 times 9.8 times 0.8 divided by 26. And we take the square root of that, and that gives us 2.0546, 2.0546. So we should write that as 3SF or 2SF. I'll write it as 3SF, 2.05 meters per second. And that's the volume, that's the velocity of this particle when it reached that point, 0.8 meters below. Okay, so when the string breaks, there's no tension. It's only subjected to the acceleration due to gravity going down the plane. And we use F equals mass times acceleration. The F max is the same, okay, which is a frictional force. The sine alpha is the same, okay, and we end up with our answer. So that completes this question, question number 8 from the January 2024 Mechanics M1 exam, and other questions from this. In fact, question number 8, and that's the last question of the paper. All the other questions you can find in the playlist, which will be linked in this area over here at the end of the video, and you'll find other questions dealing with dynamics from M1 in this area over here. You click on that, click on this, it will take you to the playlist involving forces and friction type of questions. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.